Hi guys! For this video, we're going to discuss basic matrix operations under the subject Advanced Algebra. Alright, so for today, we are going to discuss or tackle the addition and subtraction of matrices and multiplication. So we're done with the other terminologies and concepts under matrix such as the inverse, the transpose, and the adjoint features of matrices. To begin with, let us start discussing the addition and subtraction involving two matrices. So let's start with addition and subtraction first, then let's move on later to multiplication. So we have here two matrices given. In adding and subtracting matrix, we have to take note that in order for us to add and subtract two matrices or two matrix, their dimension should be the same. So let's just take note here, in order to add and subtract, if and only if dimensions are the same. So that's our good to go sign. For our first step, let us first check the dimension of each matrix given. So for matrix A, this is 2 by 2. Matrix B is also 2 by 2. So our first rule, let's check if the dimensions are the same. Therefore, we can proceed to this operation. So A plus B, 3, 4, 2, 1, plus matrix B, negative 4, 0, negative 1, 8. Then, the simple step here is we're just going to add each same location of each matrix. So we're going to add 3 and negative 4 for the first location. So 4 and negative 1 with same location. So let's proceed. 3 plus negative 4, then 4 plus negative 1. Then on the lower side, 2 plus 0. Then on the last element, 1 plus 8. Then summarizing or simplifying further, our matrix will now be 3 plus negative 4 is negative 1. 4 minus 1 is 3, 2, and 9. So this will be our final answer for this simple operation involving addition of two matrices. For our next example, let's take another example. So we are given matrix C and matrix D. So let's try to check first if their size or dimension is the same. This is 2 by 1 and this one is 1 by 2. So if we will check, their dimension is not the same. So it does not satisfy our first rule on adding and subtracting matrix, no? But if we will proceed to 4 minus negative 10 and 8, our answer will be undefined. Or in more formal way, it should be dimension error. Alright, kuha ba yan? So that's very easy, ano? So let's move on to trying an example, no, and getting the rule for multiplication of two matrices naman. So let's go on and move on to multiplication of two matrices. Ayan, so to further understand this multiplication of matrix, let us first take note, no, the rule in multiplying matrices. So our first rule is to check the dimension. This is 2 by 1 and this is 1 by 2. So for us to proceed with our multiplication operation, the row or the column, I should say, must be equal to the number of row of the multiplier. So if that's equal, we can proceed. Then the row and the column of the other matrix just signifies the size of their product. So if we will multiply this A and B, we are expecting a 2 by 2 size of matrix, ano? So let's proceed and try this one for us to further understand the operation or multiplication of matrix. So A times B will have matrix 2, 3 and 4, 1. So what we are going to do here is we multiply the first row of the first matrix to the first column of the second matrix. So it's, for example, 2. We have to multiply it to the first column, that's 4. Then we just write it here, no? So this is 2 times 4. Then the first row again, multiply it to the second column, no? To the multiplier. So for example, that's 2 and multiply to 1. So that's 2 times 1. Then moving further, we're going down the second row, 3 times 4 for the first column, then 3 times 1 for the second column. So simplifying further, this is now 8, 2, this is 12, and 3. So we come up to a product of 2 by 2 dimension. So that means it is correct. Let's try another example. So a larger matrix, so C times D. This is a 2 by 2 and a 2 by 2 matrices. So we are good to go to multiply these two matrices. They have the same number of row and the same number of column to the other side. So matrix C times D. So our first step is to multiply the first row of the first matrix, multiply to the first column of the second matrix. So this will be element 6 times 0 plus, so they are the same location. Next is 4 plus 4 from the first row ulit times the last element on the first column of the second matrix. So that's plus 4 times 9. Then we multiply the first row of the first matrix to the second column of the second matrix. So that's 6 multiplied to second column of the second matrix. This is 6 times 8. 6 times 8 plus 4 times negative 1. 4 times negative 1. Then on the lower element of this matrix, we have to multiply the second row of the first matrix to the first column of the second matrix. That's 2 times 0 plus 1 times 9. Then second row to second column, 2 times 8 plus 1 times negative 1. So our final answer, simplifying this further, C times D. This will be our final answer for this sub-problem involving multiplication of two matrices. So for you to try this, let's take an example. You may pause the video and I will flash the answer in 3, 2, 1.